Before I start seriously model building PSP28, I want to change the refinement to Phoenix. So I just want to show the setup of Phoenix. So I prefer to use the command line for Phoenix Refine because you have more control. And I prefer editing a complicated text file than fiddling with a complicated GUI. I do have a nice Phoenix file set up, but we're starting from scratch, so I'll find the documentation and we'll go from there. So let's make a directory, PSP28 Phoenix 01, and we'll start from the MTZ and coordinates in CCP4. Structure refinements. Okay, so our starting PDB will start with the last output of refmac, which is that. And our input MTZ will be, okay, I just comment the command line, press enter. Our MTZ will be P43 input files. So that's now the MTZ and the PDB. I want to generate TLS groups. We'll do that in a second. Phoenix.refine GUI. Is there a non-GUI instruction? Yes. Here we go. Default parameters. So I could just start and do that, which would be the default. We'll refine isotropic B factors, which is individual ADP plus individual sites. We could refine TLS, but we need to define sites first. We can say find automatically equals true. So we'll add that. So this is a way of modelling an isotropic B factors with a few parameters. You can look that up. nproc, we have 4 processes, so I will use 3 of them. Anything else for the strategy? We need to use non-crystallographic symmetry. We won't refine occupancies. We won't refine at this point F or F double prime, or not for this structure. We will define automatic non-crystallographic symmetry. So I only need to define this complicated command line once, and then it will generate a parameter file which can be recycled. The default are torsional restraints, which we will use. We won't use a reference model. let's flip NQ and H residues automatically. We won't pick automatic water at this point in the refinement, and we will add riding hydrogens, which I think is the default. Let's add it anyway. Our data are not twinned, we don't need to. Okay, so we've got NCS, individual ADP, so that's individual B factors, individual sites, TLS, finding TLS, 3 processors, non-crystallographic symmetry search, NQH flips, add hydrogens. I think that's not. Okay, if that's wrong, we can take the hydrogens away. Hydrogens. Riding hydrogens. I think I don't want to add hydrogens here. Let's go for that. So that's our command line. Let's just put that into a text file in case it's wrong and we need to edit it. Okay. So this should take about 10 minutes. Okay, so that failed because my input MTZ file, MTZ file, has multiple columns which Phenix doesn't know which ones to choose. So it has I-mean and sig-I-mean, but also I plus and sig-I plus and I minus and sig-I minus. So actually we need to use I-mean and sig-I-mean because we're not refining against anomalous data. So I need to add this to the command line, equals I-mean, comma sig-I-mean, and then start going again. I also forgot to add rigid body refinement to the strategy, which is probably a good starting thing to use. Everything else is the default, so let's go again. Okay, so that's finished. It's given an R3 actually slightly worse than before, but that's okay because now at least we have it in Phenix format. So to run the next round of refinement I can edit this file, which is round 2.def, and if we take a look at it, it has a space to put in the new PDB file after I've model built it, and to edit all the parameters. So if we look at running here, so I can, after I've rebuilt in Qt, I can put the new file there, and I can adjust all my parameters. So should be some NCS parameters. So it's put in TLS parameters, which probably not helping this early in refinement, but we can start again with those. Or edit those, and don't see NCS, let's search for it. So we're adding torsional NCS restraints. Okay, so as you see, Phenix Refine has many parameters. This is actually a fairly simple structure, so these don't need much editing, but if we had lots of cofactors or complicated NCS or very high resolution, we might need to edit more of this. Or very low resolution, we would need to restrain the structure more tightly. Okay, so the next step is, I think, just model build to get the structure as good as possible, and put it into refinement. So we're still at an R3 of 35 or 6, it should be possible to get this down to about 22%. So there's about 13% of our free improvements to be had, which is quite a lot. So I think there must still be quite a lot wrong with the structure that needs to be fixed in manual model building in Qt. Okay, let's do that now.